The star that refused to behave. High in the night sky, visible even without a telescope, there is a star that has confused astronomers for centuries. Its name is Betelgeuse. It is enormous, hundreds of times larger than our Sun, so big that if it replaced the Sun, it would stretch beyond the orbit of Mars. And yet, this giant star has been acting strangely. In recent years, Betelgeuse suddenly dimmed, not slightly, dramatically. Astronomers around the world noticed. Some wondered if it was about to explode as a supernova. Others suspected dust or internal instability. But the truth turned out to be far more subtle and far more fascinating. Using one of the most powerful space observatories ever built, scientists discovered something hidden, not a flare, not a collapse, but the influence of another star, a companion so elusive it escaped direct detection for decades. This is the story of how astronomers finally uncovered what has been shaping Betelgeuse from the shadows, and why this discovery changes how we understand the lives of massive stars. Why Betelgeuse has always been a mystery. To understand why this discovery matters, we need to understand what Betelgeuse really is. A star near the end of its life. Betelgeuse is a red supergiant. That means it is no longer young. It has burned through most of its hydrogen fuel and expanded outward dramatically. Inside its core, nuclear reactions are becoming unstable. This makes Betelgeuse enormous, bright, violent, and unpredictable. Massive stars like this live fast and die explosively. The star that changes shape. Unlike our Sun, Betelgeuse does not have a smooth surface. Its outer layers churn. Giant bubbles of plasma rise and fall, each one larger than the orbit of Earth. The star literally breathes. This causes natural brightness changes. But what astronomers observed went beyond normal behavior. The Great Dimming Event. In late 2019 and early 2020, Betelgeuse faded dramatically. It lost nearly 2/3 of its brightness. From Earth, the change was visible to the naked eye. This triggered global attention. Was Betelgeuse about to explode? A supernova would be one of the brightest events ever seen in human history. But something didn't add up. The star wasn't heating up, it wasn't collapsing. Instead, it looked obscured. Dust was part of the answer, but not all. Later observations suggested Betelgeuse had ejected material. That material cooled into dust, temporarily blocking its light. But this raised a deeper question. Why did the star eject material in that particular way? Why did the dimming follow a strange, uneven pattern? The behavior hinted at an external influence. Something pulling, something disturbing the outer layers. Looking for the unseen. For years, astronomers suspected Betelgeuse might not be alone. Many massive stars exist in binary systems, but Betelgeuse's glare is overwhelming. Any nearby companion would be drowned in light. To find it, scientists needed a new approach. They turned to the most precise eye ever placed in orbit, the Hubble Space Telescope. And what Hubble revealed was not the companion itself, but its fingerprint. In the next part, we'll see how astronomers detected a hidden star without ever directly seeing it. How scientists found a star they couldn't see. Finding a hidden star next to Betelgeuse is like trying to spot a candle next to a stadium floodlight. Betelgeuse is so bright, its glare overwhelms almost everything around it.
For decades, astronomers searched directly and failed. A different strategy. Instead of looking for the companion star, scientists decided to look for its effects, because gravity leaves fingerprints. If another star was nearby, it would disturb Betelgeuse's outer atmosphere. That disturbance could be detected, not with visible light alone, but with ultraviolet observations. Enter the Hubble Space Telescope. Astronomers turn to the Hubble Space Telescope. Hubble can see fine details in ultraviolet wavelengths that ground-based telescopes cannot. When scientists examined Betelgeuse's atmosphere, they noticed something unusual: a long, curved structure stretching outward from the star. It looked like a wake, as if something had passed through and dragged stellar material behind it. The wake effect. In fluid dynamics, a moving object creates a wake: a boat through water, a plane through air. Here, astronomers were seeing a wake in stellar gas. The only explanation: a companion star orbiting Betelgeuse was plowing through its outer atmosphere, pulling material, heating it, distorting it. But the companion itself remained invisible. Why the companion is so hard to see? The hidden star is likely much smaller than Betelgeuse, hotter but far less luminous overall, buried inside Betelgeuse's extended atmosphere. Its light is drowned by the red supergiant's glow. Even Hubble can't isolate it directly, but gravity never hides. Confirming the orbit. By tracking the wake over time, astronomers could estimate the companion's orbit, its distance from Betelgeuse, its mass. The data suggested the companion completes an orbit roughly every few years, close enough to interact directly with Betelgeuse's outer layers. Why this discovery matters. This wasn't just about one star. It revealed something critical. Some massive stars we thought were single are not. Binary interactions can strip stellar material, trigger mass ejections, alter how stars age and die. Betelgeuse's mysterious behavior now had a cause, not internal chaos alone, but an unseen partner reshaping its destiny. A new way of seeing the universe. This discovery proved something powerful. You don't always need to see an object to know it exists. You can see its influence, its effect on the space around it. This technique is now being used to study other massive stars across our galaxy. In the next part, we'll explore what this hidden companion means for Betelgeuse's future and whether it changes the chances of a nearby supernova.
Will Betelgeuse explode sooner than we thought? Whenever Betelgeuse makes the news, the same question follows: is it about to explode? A supernova from Betelgeuse would be one of the most dramatic events ever witnessed from Earth, bright enough to be seen during the day, visible for months, a reminder of how violent the universe can be. But does the discovery of a hidden companion change that timeline? How massive stars die. Massive stars don't explode randomly. They explode when their cores run out of fuel. As fusion reactions stop, the core collapses. Then, in a fraction of a second, the outer layers rebound violently. That's a supernova. For Betelgeuse, this will happen someday. The question is, when? The companion's influence. The newly discovered companion star adds a new layer to the story. As it orbits Betelgeuse, it interacts with the giant's outer atmosphere. This interaction can pull material away, trigger surface instability, shape mass ejection events. But here's the key point. These effects happen in the outer layers. A supernova is decided deep in the core, and right now, there is no evidence that Betelgeuse's core is collapsing. Why the Great Dimming was misleading.
When Betelgeuse dimmed dramatically, many assumed the end was near, but supernova precursors look different. Before a true explosion, scientists expect to see rapid internal changes, strong neutrino signals, increasing core instability. None of that was observed. Instead, the dimming was caused by a surface mass ejection, cooling dust blocking light, and external disturbance from the companion. In other words, Betelgeuse looked sick, but it wasn't dying. What the models say. Stellar evolution models suggest Betelgeuse still has tens of thousands of years left. That sounds long, but in cosmic terms, it's the blink of an eye. The companion may slightly alter how Betelgeuse loses mass. It may change what kind of supernova it becomes, but it does not appear to push the star toward immediate collapse. Why astronomers are still watching closely. Even if the explosion isn't imminent, Betelgeuse is unique. It's close, only about 640 light-years away. That makes it the best laboratory for studying the final stages of massive stars. Every change matters. Every disturbance teaches us something. The bigger picture. This discovery reminds astronomers that stars don't live in isolation. Their environments matter. Their companions matter. The path to destruction is often shaped by interaction, not just internal physics. In the next part, we'll zoom out even further and explore why this discovery changes how scientists study massive stars across the universe.
Why this changes how we understand massive stars. For a long time, astronomers believed they understood the basic life cycle of massive stars: born alone, live fast, die young. But discoveries like this are forcing science to rewrite that story. The myth of the single star. For decades, many bright stars were classified as isolated. They appeared alone in the sky. Their brightness drowned out anything nearby. But modern observations are revealing a different reality. A large fraction of massive stars are not single at all. They live in binary systems, sometimes with companions so close their atmospheres overlap, sometimes with partners hidden inside their outer layers. Why companions matter. When two stars interact, their evolution changes. Mass can be stripped away, rotation speeds can increase, surface eruptions can be triggered. Even the type of supernova a star produces can be altered. This means something critical. You cannot fully understand a massive star's future by studying it alone. You must understand its relationships. Betelgeuse as a test case. Because Betelgeuse is nearby and bright, astronomers can observe details impossible to see in distant stars. The hidden companion acts like a probe. Its orbit stirs the outer atmosphere. That motion reveals structure, density, and behavior scientists could only guess at before. It turns Betelgeuse into a living laboratory. A new tool, indirect detection. One of the most important lessons from this discovery is methodological. Astronomers didn't find the companion by seeing it directly. They found it by observing effects. This approach is now being applied elsewhere, to other red supersurgents, massive stars nearing collapse, stars surrounded by dense dust. The universe is full of objects that hide in plain sight. Gravity reveals them. Rewriting stellar models. With binary interactions included, stellar evolution models are being updated. These models now better explain unexpected mass loss, strange brightness variations, and irregular eruption behavior. The result? Predictions become more accurate. Supernova models improve. Chemical enrichment of galaxies is better understood. Why this matters beyond astronomy. Massive stars are cosmic engines. They create heavy elements. They shape galaxies. They seed future star systems. Understanding how they live and die is not academic. It explains why planets like Earth exist at all. A shift in perspective. This discovery represents a broader shift in astronomy, from static objects to dynamic systems.
from lonely stars to interconnected environments. The universe is not a collection of lonely points of light, it is a network of interactions, and we are only beginning to understand its complexity. In the final part, we'll step back and ask what this discovery really means, not just for Betelgeuse, but for how humanity reads the stories written in the stars. What this discovery means for the future of astronomy. The discovery of a hidden companion near Betelgeuse did not come with an explosion. There was no flash of light, no sudden collapse. Instead, it arrived quietly, as a subtle wake, a distortion in gas, a fingerprint left by gravity. And yet, its impact may be profound. A reminder of how little we see. For centuries, astronomers believed they were observing the universe directly. But discoveries like this remind us that much of the cosmos is invisible, hidden by brightness, obscured by dust, masked by distance. What we see is often only a surface layer. The real story lies beneath. From objects to relationships. This discovery shifts how astronomers think. Stars are no longer treated as isolated objects. They are systems. Their behavior is shaped by interaction, by gravity, by unseen companions. This perspective changes everything, from how stars evolve, to how they explode, to how galaxies grow. A new era of stellar forensics. Astronomy is becoming less about images and more about evidence, motion, heat, disturbance. The universe leaves clues, and scientists are learning how to read them. Indirect detection, finding the unseen by its effects, will guide future discoveries, not just for stars, but for planets, black holes, and structures yet unknown. Betelgeuse as a messenger. Betelgeuse will someday explode. When it does, humanity will witness the death of a star with unprecedented understanding. Not because we predicted the exact moment, but because we listened long before the final act. Every observation today adds context to that future event. Why this matters to us. The elements in our bodies were forged in stars like Betelgeuse. Iron in our blood, calcium in our bones, all born in stellar death. Understanding how stars live and die is understanding ourselves. We are not separate from the universe. We are shaped by it. The quiet power of science. This discovery was not dramatic. It required patience, precision, and the willingness to question what seemed settled. That is how science moves forward, not in leaps of certainty, but in careful steps toward deeper truth. The final thought. Somewhere in the night sky, Betelgeuse still glows, still unstable, still changing, and now we know it is not alone. The universe rarely is.